Hello friends, welcome to this video about the basic binary division. The objective of this video is to explain the general approach on how to divide binary numbers. Up to now, in the previous videos, we have seen successively binary addition, binary subtraction and binary multiplication. So now it is the turn to binary division. This is the first video of a set of videos dedicated to the design of binary division circuits, and it is issued as a basis to support these next videos. How it is done? Basically, the binary division is similar to the decimal division. To quickly refresh the typical division procedure, let's take an example. Suppose we want to divide 178 by 6. This is the decimal division. This is the dividend and this is the divisor. And as a result, we get the quotient and the remainder. Let's see what we are exactly doing in this decimal division. Because the first digit of the dividend is smaller than the divisor, we take the first two digits of the dividend to compare with the divisor 6 to see if it goes or not. In the quotient, we write how many times can go. In this case, can go 2 times. So we perform a multiplication of 2 times 6 and then we perform a subtraction. After performing the subtraction, we get the partial remainder, in this case 5. Then we bring down the next digit of the dividend. And we repeat the process, subtracting and multiplying until all the bits of the dividend are covered. So that is how we usually perform the division in decimal. As a result, the final remainder is 4 and the quotient is 29. Now let's see this example in binary. The dividend 178 in binary is this number, and the divisor 6 in binary is this. So this is the example in binary. The process is practically the same, so let's start. First, we are comparing the first 3 digits of the dividend with the divisor 110 to see if it goes or not. Because the divisor is bigger than the first 3 digits, in this case we need to write 0 in the quotient. Now we need to try it with the first 4 digits. So we compare again, and in this case the divisor goes because it is smaller. So we write 1 in the quotient and we make the subtraction. Now we bring down the next bit of the dividend and we compare again to see if it goes or not. In this case it goes. So we write another 1 in the quotient. And so on, we continue the process comparing and performing the subtractions. At the end, after all iterations, once we have covered all the bits of the dividend, we get our final quotient and the remainder. So, in binary division, the process is practically the same than in decimal. In fact, since the binary number consists of only ones and zeros, there is no need to perform any multiplication. What are the basic equations? These are the two main equations that govern the division. One for the division equation and one for the partial reminders. This is the dividend. This is the divisor. This is the quotient. And this is the remainder. But in the equation of the partial remainder, where this 2 to the power minus 1 comes from? The answer is that it comes from the process of shifting right the divisor bit by bit. At the end of this presentation, an additional slide is included as an appendix to explain this in more detail. Now we can easily observe that when the remainder is 0, there is an analogy between the multiplication and division. The division equation is this, and the multiplication equation is this. So there is a correspondence between the dividend and the product, the quotient and the multiplicand, and the divisor and the multiplier. So, from the point of view of computer organization, we can take advantage of this analogy when designing the process data paths of the circuits that we use for the division. That is why in the next videos we will see that very similar kind of circuits and very similar kind of algorithms can be used for multiplication as well as for the division. Nevertheless, despite these similarities, there are two things that make division more complex than multiplication. The first is that during the process of division, we obtain successive partial reminders. And the second is that one characteristic step of the division process is to check where the division goes. If it goes, means the divisor can be subtracted and a quotient digit can be obtained. If it does not go, means that the most significant digits of the partial remainder have a value less than the divisor. In this case, to proceed with the subtraction, you need to bring down the next digit and to make a shift of the divisor by one digit to realign it with the new remainder. So, let's see again the division process in detail. So basically, the division process is composed of 4 steps: comparing, bring down, shift right, and subtracting. Comparing means checking where the divisor goes. If it goes, means the divisor can be subtracted and a quotient digit can be obtained. If it does not go, means the digit of the partial remainder have a value less than the divisor. In the bring down step, if we cannot subtract because the divisor is bigger, we write 0 in the quotient and we bring down the next bit of the dividend. In the shift step, we shift right the divisor and we compare again to see if it goes or not. And subtracting, because with the successive subtraction we obtain the partial reminders. This is the flow diagram of the basic division process. Let's explain it. This is the dividend. This is the divisor, and these are the partial reminders. Here we compare the divisor with the partial reminder. If the divisor is less than the partial reminder, it goes. We can subtract, and we get the next partial reminder. If the divisor is bigger than the partial reminder, it does not go. We cannot subtract, so we write 0 in the quotient. Then, in both cases, we bring down the next bit of the dividend. And we shift right the divisor one place. This is the iteration loop. Once all the bits of the dividend have been covered, we get our final quotient and the remainder, and we stop. In summary, binary division is similar to the decimal division. A critical step of the division is the comparison to check if the divisor goes or does not go. Note that the only arithmetic operation involved in the binary division is the subtraction. Why? Because since a binary number consists only of ones and zeros, there is no need for multiplication. At the end, after all iterations, once covered all the bits of the dividend, we get our final quotient and the remainder. And there is a correspondence between division and multiplication, but division process is more complex than multiplication. That's all for today. Thank you very much for your attention. Have a nice day. If you like this video, please hit the like button and subscribe for more videos. This is the appendix slide to further explain the partial remainder equation, in particular to explain where the 2 to the power minus 1 comes from. You can go through by yourself. Thank you. In the next videos, we will explain 2 other methods of binary division, the restoring division and the non-restoring division. So, keep in touch.